Assalamu alaikum everyone. In today's video we will be solving question number 7 to 10 of exercise 3.4. So this is skill 3.4. Apply Venn diagrams for classification and cataloging with 2 or 3 sets, demonstrating advanced set theory applications in complex scenarios. So set theory is basically a very advanced, the topic of maths. So we will start. You can see after question number 4 it is question number 7, so that's why we will start with question number 7 to 10 and we will do till question number 10 in this video. So we need to prove the identities or the De Morgan's law are there, and then we need to verify using Venn diagrams also. So let's start. These questions are questions of proof. In proof, basically you need to prove that left hand side answer is same as right hand side answer. So in the 8th question and in the 9th question as well, you can see it's all about verification or proof. So you need to prove that two sides are equal based on the given question. So in the last question you can see that it is also verify question, but the difference in the question number 10 is that it is Venn diagrams question. So let's start with question number 10. A, B and C are given and we need to prove the following identities. So first part is basically not distributive, it is basically commutative identity or commutative law or commutative property of intersection, that A intersection B is same as B intersection C. So very simple question. A intersection B would be 2, 4, 6. So this is your left hand side. Right hand side is B intersection A. So B intersection A is also 2, 4, 6. So hence proved. So second part is again commutative identity or property or law of union. So again we will take left hand side because we need to verify this law. So left hand side answer is 1, 2, 3, 4, 5, 6. So you can see left hand side is equal to right hand side. So moving on to third question. For that let's talk about this again, that in this question B is subset, balki proper subset of A. What does that mean? That means that all the elements of B are part of set A. So moving on to third part is A intersection B union C. So this is distributive law or distributive property of intersection over union. So you can solve left hand side and your answer is on the screen. So then take the right hand side, find out A intersection B. So I have solved it thoroughly for you so that there is no ambiguity. Then find A intersection C. Intersection is common elements, so you need to find those. So now take the union of the two sets. 2, 4, 6 union 1, 3, 5. So it will become the same set as it is for the left hand side. Moving on to question number 4. Question number 4 is distributive law of union over intersection. So now you can take left hand side again, find B intersection C. So there is no common element, then A union would be definitely A. So right hand side now A union B. So this is set. So A union C, the same set A. So now intersection is again the complete set A. So it is same, left hand side is same as right hand side, hence verified. These 3 dots mean hence verified. Moving on to question number 8. U is given, A and B are given, and they are saying that verify De Morgan's law by Venn diagrams and by analytical method. So Venn diagrams are basically actually in my opinion there was no need to give the elements of these sets, because without even elements, we can easily prove it through both methods. Venn diagram method you can see on your screen. A union B naught is same as A naught intersection B naught. So basically, that De Morgan's law is having two parts. So this is first part of De Morgan's law. So intersection is, so you can see only this part will come. So shading of both left hand side and right hand side is equal. So this is proved by Venn diagram method. So let's take the second part of De Morgan's law, which is A intersection B complement is equal to A complement union B complement. So A intersection B is the tick mark and rest all will be shaded. So A naught is represented by a tick mark. So then B naught it is represented by a cross. So you can see this is all B naught. So union is there, so everything will come be shaded. So this both sides are equal. So now let's see what analytical method is. Analytical is basically a logical proof. So for the first part you can see A union B complement is A complement intersection. So you will say let X belongs to A union B complement. So X, it means that X does not belong to A union B. So X does not belong to A and X does not belong to B. So then it means that X belongs to A naught and X belongs to B naught. So now if we convert it into the other form, X belongs to A intersection A complement intersection B complement. So it means that A union B complement is subset of A complement intersection B complement. So now conversely, let X belongs to A naught. So you can see that same method we are following and we are proving the other side of the equation, and we will say that hence A complement intersection B complement is subset of A union B complement. So now if A is subset of B and B is subset of A, it means that both sets are equal sets basically. So both sides are equal. So from 1 and 2 we prove that then because they are both proper subset of each other, so it means they are equal. Both sides are equal to each other. So we will prove the second De Morgan's law using the same concept. So you will take again X belongs to A intersection B whole complement, then you will follow the same steps. So here this is very important. X does not belong to A and X does not belong to B. So it means that either X belongs to A naught or X belongs to B naught. So that's why the union is coming, because union means that either one of the set, the element is in any one of the set. So you can conversely prove also. So again from 1 and 2 we have proved that both sides are proper subset of each other. So this is only possible when they are both equal. So if you will practice it in 1 or 2 times, so you will be good in this this concept. So moving on to next question, which is again question of De Morgan's law. This time the values are given. U is equal to N. N mean natural numbers. A is empty set and B is equal to P. P means prime numbers. So let's see, we have to prove first part of De Morgan's law. A union B would be P and A union B naught would be N minus P. Now N minus P are basically all the composite numbers because prime numbers are subtracted. So now let's take right hand side. A complement is N minus empty set, so it is still N. B complement is N minus P, so it is basically the set of composite numbers only. So now you will take intersection, so only the composite numbers will come, so which are equal to the right hand side. Let's take the second part. You can say A intersection B is empty, A intersection B naught is N. So right hand side is A complement is N minus empty set, so it is N. B complement is N minus P, so they are all composite numbers. because you have subtracted the prime numbers from the list. So now you are taking union. So union would be natural numbers only. So left hand side is same as right hand side. So hence proved that we have proved the De Morgan's law. So now let's move on to next question. Venn diagrams we need to use. First part is A intersection B naught is A if and only if A intersection B is empty set. So it means that A and B does not have a common element, and this is only possible when they are disjoint sets. So you can see that two sets are disjoint, they are not overlapping. So A is represented by a tick mark, B naught is represented by a cross. So now the common is A, of course. So you can see which is equal to right hand side. There is no need to draw right hand side because it is A. So you can easily prove this through this Venn diagram. So moving on to second part. Second part is A minus B union B is equal to A union B. So A minus B is represented by a tick mark. So you can see only this part. So union B means that the B would also be coming. So this is the shaded region. You can see that both sets are shaded. So this is the left hand side, and on the right hand side you can see A union B is simply that means both sets are there, so they are equal. So now third part is A minus B intersection B. Now this time they are taking intersection. So you can see A minus B is only this part, which you can see on your screen also. So just the elements which are there in A, not the common elements. So B is not even there in A, so it's an empty set. So last part is A union B is equal to A union A complement intersection B. So A union B means all the both sets. So A is represented by 0. A complement is represented by tick mark, you can see on your screen. Intersection B is there, so it means the outer side would be gone because intersection is there. So only the intersection of cross and tick will come. So cross and tick is only there in the only elements of B. So now if you take union with A, so means the both sets A and B and their common elements will also be coming. So left hand side is same as right hand side. That's all everyone. Thank you for watching.